Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're back to working over here on our pouring mandrel for the big monster cane mill project, and we're going to kind of pick up where we left off in the last video. Been working on this. I got the one end already machined down to size. The other end over here is the one I started on the big lathe, and we was running into a bunch of just all kinds of chatter problems over there until I came over to this lathe. And right before I pulled it off, it gouged a pretty big slot in the side over here. I could probably get by with not worrying about it because it's right on the edge and it's kind of outside the area that the bearings will be poured. But I think what I'm going to go ahead and do is just weld it up and turn it on out so they don't have to even worry about trying to get by with it. So let me kind of zoom in here and show you what we're starting with. We've still got a lot of metal to take off of this one. I just basically made a couple passes over there and realized that it was just giving me too much chatter and too much vibration, and I was just getting a terrible finish. So I think we can do a lot better. Over here, we're going to be basically working right up next to the chuck. I got the steady rest still in here. I think we'll be all right turning it on this lathe. We'll see in a minute, but before we do that, let's get this welded up. Let me show you what we got to deal with. First off, you can kind of see what kind of finish I was getting. It was really, really rough, not a smooth finish at all. But over here on this end, I started feeding in and I was trying to take a little bit heavier cut, and it just really started vibrating badly. And you can see where my cutter just gouged in right here in a couple places, took a really deep cut in a couple places, was just kind of skipping. That was the problem. That tool was just kind of bouncing in and out over there. So like I said, I'm going to weld that up, and then we're going to go ahead and turn this back down. You can see right here, we hadn't even gotten down to the cutting a solid. It was still the rough surface there, so I really hadn't taken much off of this before I abandoned over there to come over to this lathe where I think I can do a little better job. Let me get my welder set up over here, and we'll see if we can weld that gouge up and turn this one out and have this mandrel finished up. All right, we're gonna just use the MIG torch here, MIG welder, to weld these in. Let's see, let's start right here. All right, I think that's welded up all the way around. We'll let that cool for a couple minutes and get that turned off. All right, let's give this a try. We're gonna come in here and start by knocking this weld down a little bit. That ought to get it knocked down enough we can make a pass across the whole part now, I think. All right, let's come out. We'll touch out here. We got a lot more run out on this end. I'm just going to start with about a 60 thousandths cut and see what it does. I can see a little vibration still in the part, but we're going to let it roll and see what it looks like. Tell that weld's a little bit harder than the rest of the metal, but it's cutting right through it. All right, that didn't look so bad. Let's get out here and get a measurement on that. Yeah, it's still pretty darn rough, but I think we can slow down and get some of that. I need to probably just get some metal off right now, though. We're getting down closer to the finish line, and I got a much better finish going on now. Slowing my speed down and taking a little bit lighter pass. Let's see where we're at. We are at 275, 85, 90, 92. So 2.992. Yep. Let's put that in digital readout. 5.2992. We were real close to it, but I want to get it down to size here. And I got a couple more. I'll probably do this another couple of passes, just taking some lighter passes until we get to that final finish cut, which we'll probably just fuzz off a couple of thou on it and try to get a nice finish on it. All right, let me do another 20, I think. We'll bring you guys back in a bit. Should be really close. We're going to make one more little light pass on this, I believe, to get to where we're going. Yep, we need, see, what are we at? We're at 50, 65, 67. So I got 7 thousandths to come out of this. I'm just going to dial that in there, and we should be ready to go. Going to just dial it in right to 260 on the digital readout, and this will be the final pass. All right, here we go. Slow down, light feed. Got a fresh insert in there. This should give us a decent finish. We're going to let that run on across, and we'll check it out once we do. Yeah, we'll put a little polish on that, smooth it up a little bit, but I think that's going to be fine. And before I get out of here, I want to break those corners. Do both sides. And I'm going to hit this with the belt sander a little bit just to polish it a little bit. And we're within a thou of where we need to be, which for this purpose is plenty good enough. So I think we're done. I think we got that knocked out. All right, so this is looking good. We've got the mandrel done. We've got our sizes for our two journals here that we'll be pouring against. The next step in this process, though, is that we got to get this shaft properly positioned. They can't be just sitting on the bottom like this. We got to let the bearing material go up underneath it. So I'm going to make some collars that will fit up over this and fit into these little pieces here to support this and hold it into place. And these collars will also serve as being a dam to hold that babbitt in to keep it from running out the end. Let me show you what I'm going to make these out of. So when I had these little discs cut out that we welded on the ends, I also had a larger disc cut out of the same piece. So basically this is the part that came out of the inside. But this outside collar, what I'm going to do is we're going to turn this so there's a little step in here that will fit into this ledge, and we're also going to turn this inside diameter where it'll fit up over the shaft. And the idea here is that this is going to support, the inside bore will support the shaft, and then that little step in there will just barely fit into these steps here, and then we'll put a couple of clamps on there, sandwich them together, and that will position the shaft so that it's running straight across and positioned in the right place, and at the same time dam that end up so that the metal doesn't come out when we're pouring. That's my game plan anyway. So we've got to get over to the lathe and get these bored out to the right size, and then also get that little step machined into them. And once we do that, I think we'll be ready to pour some babbitt bearings. So let's go set up on the lathe to turn these little fixtures that's going to hold this in place. So on these discs, my plan was to come in here and just put these in the lathe and bore them out. But I got a problem. The problem is that the way these jaws are, you can see the back of the jaw is actually above the area that I got to bore, and I need to be able to clear that with the boring bar. So this isn't really going to work. Now, I could get some soft jaws and basically make some custom jaws that gave me the proper clearance behind it, enough lip to catch it back here at the top, but basically kind of notching that out. But I don't have any soft jaws in stock here in the shop right now. I'd have to order them. This is late in the week. It'd be next week before they got here, and plus, you know, looking at the cost of having to bring those in just for boring out 4 little discs, it's just not worth it. So I think we're going to go plan B here. And instead of boring this out on the lathe, we're going to bore it out on the milling machine. We'll just use the boring head and set these up and just bore them out over there. It'll be quicker, easier, and well, I don't know if it'll be quicker, but it'll be easier than, you know, doing the soft jaws and all that. And it really won't cost me anything except time. So that's what we're going to do. All right, let's take a look at our setup here. I decided that since we had to do these, we would just do a stack of them and do them all at one time. Hopefully I can get through this without these moving around. I think we will. We got them clamped down. I got them sitting up on some 1, 2, 3 blocks just because I need some clearance up underneath the bottom for the boring head to go down and clear. Because of the size of this boring head, I really couldn't use it out of the bottom. It was going to be sticking out too far, but there's a hole in the end that you can put your boring bar in there and sweep around in a larger diameter circle, which is what we're going to do. So, yeah, let's just go ahead and tell you what I'm going to do. I think to start with, I've kind of just got this thing centered up, more or less, just by eye. Let's see what we need to do here. I'm going to go ahead and just pull this out to where my cutter's probably just barely kind of making contact all the way around. I'm going to make one pass all the way through. Once we do that, we'll go ahead and usually with this boring bar, I can cut, I don't know, 50 thousandths per pass, something like that. So let's give it a try. All right, I think we are ready to go. I'm going to just feed this down by hand until we're just touching there. Now I'm going to engage my down feed. I'm cutting 3 thousandths per revolution down. And we're making contact most of the way around. It's just that's a pretty rough inside diameter right now on that cut. And each one of them is lined up about as good as I can get it, but none of them are perfect. So we got a good bit of material to take out of there. So we'll just go on down through here. And past the third plate here. Starting on the fourth plate right now. It should be coming out the bottom. And come back up. All right, now I'm going to feed this in about 50 thousandths to me. And we'll take another pass. And we'll let her feed down. I'm making more of a uninterrupted cut. I'm cutting a lot smoother than when we were making an interrupted cut. And we're still making an interrupted cut on some of the plates, but we're starting to get all the way around on them. The inside cut on the flame cut was not super uniform, so we're kind of having to get through that. And I pretty much got, I think, a diameter that I can measure now on the top to kind of figure out where we're at and where we're going to. I've gone to a 6/1000 down feed. This goes to a little bit quicker and seems to be cutting just fine at 50 thousandths per depth of cut. I'm going to get some calipers and measure that, and we'll continue on. This is just a rough measurement, but we're at about, what is that, 4 inches, 815 thousandths. And we need to go to about 5/265 or so. So we got quite a bit to come out. So, all right, take another 50. Well, guys, ran into a little problem here, and unfortunately I didn't have the camera running because this would have been a fun one. I noticed when I was doing this, I had my boring bar in here. This wasn't the actual bar, but it was in there sticking out. And I noticed that to run it in this side mode, the way the insert is positioned, I was having to run this basically in reverse from what you normally do when the cutter is out here, because this way it's on this side, so the tool is swinging this way. When you put it on the side, the tool swings towards you this way. I didn't really think that was going to be an issue, but I did not realize that this top and bottom piece screw together. If you look, that unscrews. I'm really surprised that it went as far as it did without coming unscrewed, but in the middle of this last cut that I was making, it unscrewed itself. And when it did, it didn't mess anything up. You know, it kind of made a little ugly spot right there, but nothing we can't deal with. What do we do? You know, I dug around and looked, as there's no way to mount this cutter. If I flip it around the other direction, it's still cutting in the same direction. The only thing I could do is flip it up and mill it cut from the bottom coming up. I don't really like that idea because I got upward pressure rather than downward pressure going into my table. Plus, I didn't have room when it goes down the bottom to clear and be able to adjust it. Once I got it below, I couldn't get my screwdriver in there to adjust it. So I dug around, and what I found was a boring bar that is actually for the lathe. It's a 1-inch boring bar, but it's a left-hand boring bar. This is for doing left-hand work in the lathe. And it will spin in the direction that we need for it to do in order to where this is going to be tightening as it's cutting rather than loosening as it's cutting. I think this is going to work fine. I will say that, you know, this was a long boring bar. I had to cut it off to make it work. Not a big deal. These boring bars are not that expensive. I will just set this one aside and have it for future jobs down the road, such as this, where we might need it. So what I'm going to do is basically just kind of put that in there, get it to where we were on that previous cut. I'm going to tighten this up, and we'll be cutting in the other direction, and that will be tightening this on that threads rather than loosening it, and hopefully it shouldn't be a problem again. Always something. All right, let me get this going. Tell you what I'm going to do. I'm going to actually, feed it in from the other side. Loosen that up. The only difference here is that I've got my set screws. There's a flat on the toolbar, and I want the set screws to be going into the flat rather than on the other side. So I just flipped it around 180. We'll do the same thing. I'm just going to bump that out until it touches right there. And we'll kind of have to reestablish ourselves, but no big deal. At least it wasn't on the last cut that I did this and screwed everything up, because that's typically my luck. But we'll adapt. Fortunately, I had that boring bar here. I didn't have to order something. I'm going to need to order a replacement boring bar so that I have one for the lathe that's full length. But we make it work. This was actually over in my drawer of kind of excess parts that I've accumulated over the years. I don't know that I've ever needed a left-handed boring bar in that length, that size before. All right. I think we are ready to go again. I'm going to fire this back up. I did purposely cut this so that it would just barely clear on the back side. I wanted this to be as long as I could so that if I needed it for a job down the road, I can always make it shorter, but I can't make it longer. I didn't want to cut off any more than I absolutely had to. All right, I'm going to just probably feed this out just a couple of thou, and then we're going to go down that cut and get her going here. So let's see. We are cutting all the way around. Let's make a little bit heavier cut there. All right, we're going to take a deburring tool and just deburr these lightly on the inside, on both sides. Take any burr off of that. All right, so, yep, that slides right over. That's exactly what I want. So again, this is going to dam up this outside gap. And the other thing I've still got to do is I got to machine a step in them so that it will pick this up and kind of hold it up off the bottom. And I need to figure out what that needs to be. We'll have to do that over on the lathe. So let me figure up those dimensions, and we'll get that done. So we got a radius in here that is larger. The shaft is 5 1/4 inches, and this looks like it's 6 inches. Yeah, so this is a 6-inch diameter. The inside diameter is 5 1/4, so that's a 3/4 inch difference. So basically I need a 3/8 inch step all the way around to get this one properly sized. I'll have to go over there and we'll just machine 2 steps. That step will ride right in this little saddle and have a lip that comes out to cover up the outside, and then support the shaft on the inside. We'll do one for the inside and the outside. And then we got to do the other side. The other side is different. Let's go take a look at it. So this side over here, the main diameter from here to here is again 6 inches. But if you look, this one has a little lip in the inside. This is kind of a dam to kind of help keep that babbitt in there. I don't know why they don't have the same thing on the other side, but they don't. And I've kind of already measured this and figured out it's got a little chip on both sides. This makes it a little bit difficult, but I measured how high that is. And basically, I need to turn this diameter to fit into this little slot 5 3/8 of an inch, which is only going to give me about just a little bit of clearance between the shaft and this right here, but it's going to be fine. We'll have a little bit of babbitt area in there as well. So I got my measurements now. Like I said, there's going to be 2 different sizes that we need to cut that lip to, but let's go over to the lathe and we'll see if we can get that knocked out. All right, so I got my ring over here. I got it chucked up in the lathe. We're just gripping it on the inside. And again, what I want to do is I want to machine in a step that is what I got, 6 inches and 5 3/8, whatever. I got my numbers over there. And we're going to go about half the thickness. This is 3/8. We're going to go 150 thousandths deep. So we're just going to cut a little step in there that will sit on that little ledge and still leave us the outside here to cover it up. So let's get over here and we can start working on this. Just kind of facing it here. All right, I'm going to stop right there. Put my calipers on that and get a diameter so I can kind of see how far. That's more than 6 inches, so let me grab a different set of calipers. It's a set of 12-inch diameter calipers here. And we're at 6 to 12. 6.212. Go back to the back and then face all the way out. And that should be my first one. I need to do the other ones so they all fit. I'm going to go double check that to make sure it fits in there just right. And we'll cut these things out. We'll be ready to set that in there properly positioned. So hopefully you can see now what we've got. We've got these spacers in here, and that's got that clearance all the way up underneath the bottom, just like we need for the proper bearing clearance. And when we put the end cap on the end, slide that in there, just drop it in there. That's going to support it on both ends, and it's also going to cover up that little gap so that when we pour the babbitt in there, it will hold it all in. We'll use some damming material in here just for added insurance, but this right here will do most of the work. And you've got a little bit of a gap around the outside, but again, we'll put some damming material around that, but that should hold everything in place. That properly position the shaft. The mandrel is set up to be the same diameter as the shaft that'll go in there. This should allow us to get our babbitt bearings poured just like we need to without having to put the actual roller in there. And we've got the same thing on the other side. Now this one here, again, we don't have as big of a gap, but there is on the inside the gap. This has just got a little lip around it. We'll put the spacer in there. There we go. I think we got this ready for babbitt bearings. Well, I won't lie, this pouring mandrel has been a lot of work. But I'm real happy with how it turned out. I think this is going to really work well for us. And up next on this project, we'll be pouring these bearings. We'll do both the bottom halves and the top halves. We'll get the shaft in here, scraped in, running like it needs to. But this is going to by far, I think, be the most complex bearing pour on this whole casting whole job we got to do, although there are some more bearings that have to be poured. We have to do the bottom rollers, but those are a lot easier to do. We can pour each one of those individually. They're just kind of pads that press up on there. There's also some rollers down here for the gearing and stuff. We'll have to deal with those when we get to them. But again, this is going to be the most complex of all of them as far as the difficulty involved in getting everything just right. So with that, I think we got our pouring mandrel done. We're ready to actually pour the bearings. That'll be coming up soon in another video. But we're going to be signing off on this episode and bring you back later. Continue working on this cane mill project. So guys, as always, thanks so much for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted. As always, a big, huge thank you for those who support the site financially through Patreon and PayPal. And with that, guys, we are going to sign off, and we will catch you on the next video. Again, thanks for watching.